Welcome second year B.Sc student, paper number MTS 301, calculus of several variable, video number 29. Unit number 4, double and triple integration, and this is video of more example on double integration. Dear friend, first subscribe my YouTube channel PV Patil. Example number 1, draw the sketch of the region of integration limit 0 to 4 dx, integration limit 0 to square root 25 minus x square f of xy dy. Means draw the sketch of double integration. First integration 0 to 4 dx, second integration limit 0 to square root 25 minus x square f of xy dy. Means in first integration these are values of x, means x is 0, x is 4. X varies from 0 to 4 and y varies from 0 to square root 25 minus x square. Therefore the region bounded by x is 0, x is 4, means these are two lines, x is 0, x is 4, and y is 0 and y is equal to square root 25 minus x square. The region is bounded by these lines, x is 0, x is 4, y is 0 and y equal to square root 25 minus x square. Now this region is not a line. Simplify this equation and find out this square. So squaring both sides we get y square equal to 25 minus x square. Write down this minus x square on left hand side. So we get x square plus y square is equal to 25. X square plus y square equal to 25 is a circle in standard form whose center, origin and radius is a square, means here is 5 square, so radius is 5, is a circle with center 0 0 and radius 5. So draw the sketch of this region. X is 0, x is 4, y is 0 and x square plus y square equal to 25. This is a circle with center 0 0, radius 5. So for that, first draw x axis and y axis. This line x axis and this line y axis. So equation of x axis is y equal to 0 and equation of y axis is x equal to 0. This point is origin 0 0, origin 0 0. Now draw the circle x square plus y square 25, center, origin, radius 5, center, origin and radius 5, center, origin, radius 5. So circle is in this way, center is origin and radius 5, means here is this point is 5 0. Now draw the line x equal to 4, x equal to 4, this point is x is 5 because radius is 5, so this point is 5 0, so 4 0 point is here, so this line passing through 4 0 point is line x equal to 4. This is line x equal to 4. Now region in between x is 0, this line, next line x is 4, this line, then circle and y equal to 0, this line, means this line x is 0, x is 4, these two line, then y is 0 and circle, means only this portion is required region. Region is this portion in this way. This portion is required region. X is 0, x is 4, y is 0 and circle. So only this portion is region. This is sketch of given double integration. Draw the sketch of the double integration. First integration limit minus 1 to 3. Second integration limit x square to x plus 3 f of xy dx dy. Now here draw the sketch of this double integration. Here limit of integration from x square to x plus 3. These are in terms of x, so these are values of y. Means y equal to x square to y equal to x plus 3, and these are values of x. X equal to minus 1 to x equal to 3. Means x varies from, here x varies from minus 1 to 3 and y varies from x square to x plus 3. X varies from minus 1 to 3, y varies from x square to x plus 3. Therefore the region bounded by, the boundaries of the region bounded by x equal to minus 1, x equal to 3, y equal to x square, this is a parabola. Y equal to x square is a parabola, and y is equal to x plus 3 is a line. The region bounded by x is minus 1, x is 3, parabola y equal to x square, and the line y equal to x plus 3. So for that, draw the sketch of this region. So first draw x-axis and y-axis. This line x-axis and this line y-axis. X-axis equation is y equal to 0, y-axis whose equation is x equal to 0. This point is origin 0, 0. This point is origin 0, 0. Now this is the x-axis. So here negative coordinate minus 1, minus 2, minus 3. And here positive coordinate plus 1, plus 2, plus 3. On the y-axis, above side plus 1, plus 2, plus 3. And below the x-axis, on the y-axis, these are minus 1, minus 2, minus 3. Now first x equal to minus 1. So here is minus 1 point. So line parallel to y-axis is x equal to minus 1. X equal to minus 1 is a line parallel to y-axis. This line is x equal to minus 1 because this point is minus 1. Now x equal to 3. This is also line parallel to y-axis and on the right side of the y-axis. So parallel to y-axis. So this line is x equal to 3. X is minus 1, x is 3. Next one, parabola y equal to x square. This parabola is opening above the x-axis, and passing through origin. Origin is the vertex of this parabola, y equal to x square. Y equal to x square, this parabola, whose equation is y equal to x square. Now draw the line y equal to x plus 3. So for that, first find out 2 points on this line. First take y equal to 0. First put the value of y is 0. So we get x equal to minus 3. Value of x is x coordinate, means point is minus 3, and value of y is y coordinate 0. So one point is minus 3, 0. Because when y is 0, x is minus 3, so point is minus 3, 0. And when x is 0, y is 3. So next point is 0, 3. Next point is 0, 3 on the y-axis. Now the line passing through these 2 points, A and B, whose equation is y equal to x plus 3. This line passing through these 2 points, whose equation is y equal to x plus 3. Equation of this line is y equal to x plus 3. The required region is x equal to minus 1, x equal to 3. In between all these lines, x is minus 1, this line, x equal to 3, this line, these two lines. Then parabola y equal to x square and the line y equal to x plus 3. First line x is minus 1, next line x is 3, then parabola and this line. So required region is only this part. This part is required region. In all these 4 lines, x is minus 1, x is 3, parabola and this line. So this is required region, and this is sketch of the given double integration. Next, example number 3. Evaluate double integration xy dx dy. Evaluate double integration xy dx dy over the rectangle bounded by x is 2, x is 5, y is 1 and y is 2. Solution. Here x varies from 2 to 5, x varies from 2 to 5 and y varies from 1 to 2 in this way. So for that, consider x-axis, y-axis, x-axis whose equation y equal to 0, y-axis whose equation x is 0. This point is origin 0, 0. On the left side minus coordinate, on the right side plus coordinate, plus 1, 2, 3. So first line x equal to 2, next line x equal to 5, 2 line. X is 2, x is 5, x is 2, x is 5. Now y is 1, y is 2. Above the x-axis positive coordinate, so line parallel to x-axis is y equal to 1, and next line parallel to y-axis is y equal to 2, y equal to 2. So region in between x is 2, x is 5, y is 1, y is 2. This region is required region. Now evaluate integration, double integration over this region. Here given, already given x varies from 2 to 5 and y varies from 1 to. Therefore, double integration xy dx dy is equal to first integration limit x varies from 2 to 5, second integration limit y varies from 1 to 2 xy dy dx. Means first integrate with respect to y. First integrate with respect to y, therefore is equal to integration x varies from 2 to 5. Now integration of this term with respect to y, so x integration of y is y square by 2. Integration of y is y square by 2. Y varies from 1 to 2 dx. Y varies from 1 to 2 dx. Now first put upper limit, then put lower limit. So equal to 1/2 constant out of the integration. Integration x varies from 2 to 5 inside the bracket x. First put the value of y is 2. So 2 square is 4. So 4x. Minus put lower limit, value of y is 1. X into 1 square is 1. So only x. 4x minus x into dx. Now 4x minus x means 3x. So 1/2 integration x varies from 2 to 5 3x dx. Now 3 is constant out of the integration. So equal to 3 by 2 integration x varies from 2 to 5 x dx. Now integration of x is x square by 2. X varies from 2 to 5. 3 by 2 integration of x is x square by 2. X varies from 2 to 5. So equal to, now first put upper limit and then put lower limit. So equal to 3 by 4. This 2 into 2 4, 3 by 4. First put upper limit, so 5 square minus put lower limit 2 square equal to 3 by 4. 5 square is 25 and 2 square is 4. So 3 by 4, 25 minus 4 is 21. 21 into 3 is 63 by 4 is the answer. Next example number 4. Evaluate double integration x square plus y square dx dy over the region bounded by x is greater than equal to 0, y greater than equal to 0 and x plus y less than or equal to 1. So evaluate this integration and bounded by this region. So by using this equation, first find out limit of this integration. First find out limit of this integration by using this region. Consider the region bounded by lines. Consider the region bounded by line x is 0. Next one y is 0 and x plus y is equal to 1. X is 0, y is 0 and x plus y equal to 1. X is 0 means y axis, y is 0 means x axis. So for that first draw the line x and y axis. X axis equation y equal to 0. This is y axis equation x equal to 0. This point is origin 0 0. Now draw the next line x plus y equal to 1. So for that first find out 2 points of this line on the line x plus y equal to 1. When y is 0, when y is 0 we get x is 1. So point is 1 0. One point is a point 1 0. This point on the x axis. And when x is 0 we get y is 1. So next point is 0 1. This point is on y axis 0 1. The line passing through point A and B is x plus y is equal to 1. This line x plus y equal to 1 origin. Now the region bounded by x is 0 means this line, y is 0 this line and x plus y equal to 1. The region in between these three lines is required region. Now in this region x varies from 0 to this line. The line parallel to y axis is this line. This line passing through point A point 1 0. So equation of this line is x equal to 1. Means x varies from 0 to 1 and y varies from this line to this line. The strip parallel to y axis. So y varies from 0 to here y equal to 1 minus x. Y varies from 0 to 1 minus x. Therefore this region is in between these two lines and these two lines. X is 0 to 1 and y is 0 to 1 minus x. Therefore, given double integration x square plus y square dx dy equal to integration x varies from 0 to 1, integration y varies from 0 to 1 minus x square plus y square. First integrate with respect to y, so dy, and then integrate with respect to x, so into dx. Therefore, is equal to integration x varies from 0 to 1. Now integrate this with respect to y first. So in first term x square constant, integration dy is y. So x square y plus integration of y square is y cube by 3. Y varies from 0 to 1 minus x dx. Now here first put the value of y as upper limit 1 minus x, then minus of put the value of y as lower limit 0 is equal to integration limit 0 to 1 x square. Now put the value of y is upper limit 1 minus x plus again put value of y as 1 minus x, so 1 minus x cube upon 3 minus of put the value of y is 0, so this is 0, y is 0, so this term is also 0 dx equal to open this bracket equal to integration limit 0 to 1 x square into 1 is x square minus of x square into x is x cube plus 1 by 3 into bracket 1 minus x bracket cube dx. Now integrate this with respect to x is equal to integration of x square is x cube by 3 minus of integration of x cube is x raised to 4 by 4 plus 1 by 3 integration 1 minus x bracket cube is 1 minus x raised to 4 upon 4 also divide by coefficient of x minus 1 and x varies from 0 to 1. Now first put upper limit value of x is 1, so we get 1 by 3, x is 1, so minus 1 by 4. Now x is 1, so 1 minus 1 0, so this term is 0 minus of put lower limit put the value of x is 0, so this is 0 minus this is also 0. Now this term plus and minus become minus 1 upon 12 and put x is 0, so 1 raised to 4 is 1, 1 into 1 by 12 is minus 1 by 12 is equal to we get LCM in first bracket is 3 4s are 12, 12 multiply first term by 4 second term by 3, so 4 minus 3 upon 12 and this minus and minus become plus 1 upon 12. So we get 1 upon 12 plus 1 upon 12 is 2 by 12. 1 plus 1 is 2 by 12 is equal to 1 by 6 is the answer. Next example number 5. Evaluate double integration e raised to 2x plus 3y dx dy over the triangle bounded by x is 0, y is 0 and x plus y equal to 1. Given the region bounded by x is 0, y is 0 and line x plus y equal to 1. So first draw the diagram x-axis, y-axis and origin. X-axis, y-axis, equation of x-axis is y equal to 0, y-axis, equation of y-axis is x is 0 and origin 0, 0. Now we get two line x is 0, y-axis and y is 0, x-axis. Now draw next line x plus y equal to 0. So for that find out 2 points on this line. When y is 0 we get x is 1. So 1 point is 1 0. 1 0 point on the x-axis, a point 1 0. Next point when x is 0 we get y is 1. So second point is 0 1. So this point is on the y-axis, b point 0 1. Now the line passing through point A and B is x plus y is equal to 1. Now the region is in between x is 0, y is 0 and x plus y equal to 1. Means this is a triangle. This is required region triangle. Now in this region x varies from 0 to this line x equal to 1 because this line is parallel to y-axis and this line passing through point 1 0. So equation of this line is x equal to 1. Therefore x varies from 0 to 1. X varies from 0 to 1 and y varies from this line to this line. Y varies from 0 to 1 minus x. Y varies from 0 to 1 minus x. Therefore given double integration e raised to 2x plus 3y dx dy is equal to integration x varies from 0 to 1. Next integration y varies from 0 to 1 minus x e raised to 2x plus 3y dy dx. Means first is integration with respect to y. So integrate this with respect to y. So integration x varies from 0 to 1. Now integration of e raised to is e raised to. So integration of e raised to 2x plus 3y is e raised to 2x plus 3y. Also divide by coefficient of y. Also divide by coefficient of y 3 and y varies from 0 to 1 minus x dx. Now here first put the value of y is upper limit 1 minus x and then put the value of y is lower limit 0. So equal to, first write down this constant out of the integration 1 by 3. Integration x varies from 0 to 1. Now e raised to 2x plus 3 into value of y is 1 minus x, so 3 into 1 minus x minus of, put the value of y is 0, so e raised to 2x plus 0 dx is equal to 1 by 3. Integration limit 0 to 1. Now here open this bracket, e raised to 2x plus 3 minus 3x minus of e raised to 2x dx is equal to 1 by 3. Integration x varies from 0 to 1. E raised to plus 2x minus 3x is minus x plus 3. E raised to minus x plus 3 minus e raised to 2x dx. Now integrate this term 1 by 3. Integration of e raised to x is e raised to x. So e raised to minus x plus 3 divide by coefficient of x minus 1 minus of integration of e raised to 2x is e raised to 2x divided by coefficient of x to x varies from 0 to 1. Now in each term first put upper limit then put lower limit. So 1 by 3 inside the bracket minus of e raised to, put the value of x is 1, e raised to minus 1 plus 3 minus of e raised to 2 by 3 e square by 3 minus of, put the value of x is 0 means lower limit minus of e raised to 3 minus of e raised to 0 plus 3 is e raised to 3, then minus of 1 half e raised to 0 equal to, we get 1 by 3. This term is minus of e square minus 1 half e square, then this minus minus become plus e cube and this minus minus become plus 1 half plus 1 half. Now simplify these two terms, therefore we get minus 1 minus 1 half is minus 3 by 2 e square. 1 by 3 inside the bracket 1 half plus e cube minus 3 by 2 e square. Take 1 half common, take 1 half common from this bracket, so we get 1 by 6 inside the bracket 1. Now multiply by 2 because 1 half common, so 2 e cube minus 3 e square is required answer. Next example number 6. Evaluate double integration xy dx dy over the first quadrant of the circle x square plus y square equal to a square. Evaluate double integral over the first quadrant of the circle. This is circle in standard form, circle x square plus y square equal to a square. This is equation of circle in standard form whose center is origin and radius is a. So for that draw circle. Consider x axis and y axis. This line is x axis equation and this line is y axis. Equation of x axis y equal to 0 and equation of y axis x equal to 0. This point is origin 0 0. Now draw a circle whose center origin and radius a. So draw circle center origin radius a. So this point is a0. This point is a0, this point minus a0, this point is 0a and this point is 0 minus a. Now consider the region in the first quadrant of the circle. So consider this region only in the first quadrant in this way. In this region x varies from 0 to this line. This line is parallel to y axis and passing through point a0. So equation of this line is x equal to a. Mean this region bounded by line x is 0, x is a. X varies from 0 to a. And y varies from this line to circle. Y varies from this line to circle. So y varies from 0 to. Now equation of circle, x square plus y square is a square. So y square equal to a square minus x square. So y equal to plus minus square root a square minus x square. But in first quadrant y is positive. So in first quadrant value of y is square root a square minus x square. Means x varies from 0 to a and y varies from 0 to square root a square minus x square. And therefore double integral xy dx dy is equal to integration is equal to first integration x varies from 0 to a, second integration y varies from 0 to square root a square minus x square xy dy dx. Now first integrate with respect to y. First is integration with respect to y equal to integration x varies from 0 to a. Now first one integration with respect to y. So x integration of y is y square by 2. Y varies from 0 to square root a square minus x square dx. Now here first put upper limit. The value of y is square root a square minus x square. Then put the value of y as lower limit 0. Therefore is equal to integration x varies from 0 to a x into put the value of y is square root a square minus x square, its square. So is equal to only a square minus x square upon 2. Minus of put the value of y is 0. So this is 0 into dx is equal to 1/2 constant out of the integration. Integration x varies from 0 to a. This first term is a square x minus of x into x square is x cube dx is equal to 1/2. In first integration a square constant, integration of x is x square by 2 minus of integration of x cube is x raised to 4 upon 4. X varies from 0 to a. Now first put upper limit. So 1/2 inside the bracket. First put the value of a is a. So a square into a square a raised to 4 upon 2 minus of a raised to 4 upon 4. Now minus of put value of x is lower limit 0. So 0 minus 0 is equal to 1/2. Inside the bracket LCM is 4. So multiply here by 2. So 2a raised to 4 minus a raised to 4 upon 4. 2a raised to 4 minus a raised to 4 is a raised to 4 upon 4 into 2 8 is the answer. Dear friend, subscribe this channel and share to our friend. Thank you.